We speak student.
Centers of a triangle, a la shmup. For the past 60 years, food scientists, doctors, and mathematicians have worked tirelessly to answer a question that has tormented the candy industry for generations. How many licks does it take to get to the center of a Tootsie Pop? They've determined that the number of licks depends on three crucial points related to the lick: the apex of the Tootsie Pop, the beginning of lick point, and the ceasing of lick point, or points A, B, and C. If we find the centers of this triangle and determine which of them are collinear, this will help calculate the number of licks needed to reach the center of the Tootsie Pop. So, which of the four triangle centers of A, B, C are collinear? Our first order of business is to find out what these triangle centers are and draw them. Let's start by choosing a random triangle. That guy looks good. If we draw an angle bisector for each of the three angles, we'll see that they all intersect at a point called the incenter. The incenter is also equidistant from all the sides of the triangle, since it's the center of the triangle's inscribed circle. Rather than looking at the angles, we can draw in the perpendicular bisectors of each side of the triangle. They all intersect at one point called the circumcenter. No, that's not that thing that happens to little boys when they're born. This is sort of the opposite of the incenter, since it's the center of the circumscribed circle. No, we said it's not that. Get that thing out of there. If we draw in the medians of the triangle, which bisect the sides and go through the vertices, they will all intersect at another point called the centroid, distant cousin to the Google phone. The centroid is always inside the triangle and divides each median into two segments, one that's twice the length of the other. The last type of center, the orthocenter, is formed by the intersecting altitudes. All we need to do is draw a line from one vertex that's perpendicular to the opposite side. If we need to, we can extend the sides to make sure the altitudes are perpendicular as well. So just by looking at points I, M, C, and O, we can see that M, C, and O are all collinear. This line that goes through the circumcenter, the centroid, and the orthocenter is called the Euler line, and every triangle has one. Fortunately, it's looking as if we will soon solve the Tootsie Pop mystery for good. We're getting closer and closer to an answer, one lick at a time.